Hello and welcome to SGI's video on conserving mesic habitats in sagebrush country. My name is Jeremy Maestas. I'm a sagebrush ecosystem specialist with the NRCS's West National Technology Support Center based in Portland, Oregon. Our video will be broken up into 3 segments. And you're welcome to skip ahead to segments that you're interested in, but we tried to put these together to tell a cohesive story. First, we'll start with a description of SGI's mesic conservation approach, where I'll talk about why we're interested in conserving these rare resources and some of the practices that our staff and our partners have helped identify that can be beneficial. In the second segment, Patrick Donnelly from the Fish and Wildlife Service will talk about mapping mesic resources across the West. And in part 3, Brady Allred from University of Montana will discuss the SGI's interactive web app and brand new mesic resources layer. And I'll close with some tips on bringing these layers into ArcGIS framework to assist with conservation planning.
So just a little bit of background before we get started. For those that aren't as familiar with SGI, since 2010, NRCS and its partners have been helping private landowners strategically implement the right practices at the right places and at the right scale to reduce threats to sage grouse and improve ranch sustainability. We've really demonstrated that when we focus our collective cannons on a particular threat, we can make a big focused difference. And all of these voluntary conservation efforts and our strategic approach were a big part of the September 2015 decision by the Fish and Wildlife Service that sage grouse no longer warranted protection under the Endangered Species Act. So really helped, combined with the policy changes on the public land management side, helped to demonstrate that, in fact, we can scale up conservation to make a landscape scale difference. In 2015, NRCS renewed its commitment to sagebrush ecosystem conservation through what we call our SGI 2.0. 2.0 is an investment strategy that took a little bit of an improved approach where we shifted from simply practice-based implementation to whole systems that use a variety of practices to address key threats. In this strategy, we continue to address things like conifer expansion, subdivision, and other range infrastructure issues as we were previously. But we've added to that list some new arenas where we're working with public land managers on wildfire and invasive species issues. In the Great Plains, holistic approach to addressing cultivation of native rangelands. And for the first time, we added this new resource concern of mesic area loss and degradation. Really set some specific targets for each of our states across the West to contribute to addressing this particular issue in sagebrush country. Today, most of SGI's conservation efforts have focused on the sagebrush uplands, especially targeting that breeding and brood rearing nesting habitats where we know that those particular areas are important for sage grouse hens, chicks, which are key elements of the driving population numbers. And so, you know, part of what we're doing with this mesic approach is starting to think about what happens throughout the rest of the life cycle. And in particular, as that summer heat dries up the desert soils and sage grouse seek out these wetter mesic habitats which provide abundant forbs and insect food resources to feed their growing chicks. The term mesic habitat refers to a type of habitat with a moderate or well-balanced supply of moisture. In the sage steppe, we're talking about places like riparian areas and wet meadows, higher elevation habitats like in the upper right here that are really abundant in forbs throughout the summer. Springs and seeps are some of those smaller resource areas, and then even our human-modified landscapes, the irrigated fields do support mesic habitat conditions in the sage steppe. These areas serve as green grocery stores for wildlife and livestock as they stay wetter than the surrounding landscape throughout the late summer. One groundbreaking study that really got us thinking hard about the role of mesic resources was actually done by Patrick Donnelly and some colleagues and published in Ecosphere in 2016. And I just want to give a brief summary of that, and Patrick will talk later about some of the methodologies used and how that's been scaled up across the rest of the sage-grouse range. But essentially for this study, Patrick took about 20% of the range in Oregon, Nevada, and parts of California to test out this strategy of mapping mesic resources through time using widely available Landsat imagery. And so what you see here on the left is the green areas represent those mapped mesic resources during the late summer, July through September, in a wet year versus a dry year. And notice how you can start to actually watch the landscape breathe through time as we go through drought and deluge. He then took those values and related them to sage-grouse lek locations and abundance to see what patterns emerged. And you might recognize this map with the leks, the hot colors, the red are those high abundance leks where you have more males on the leks than, say, your blue areas that have just a few males on leks. One key finding from this study related to the distance of leks to these late summer mesic resources through time. And so as you plot out population abundance and the distance of these leks through time, what Patrick and his colleagues found was that you've almost always got the most abundant leks more closely situated to mesic resources that are available in the late summer, such that these sparsely populated leks were always further away. And what we think may be happening here is these landscapes that are capable of supporting more birds have more reliable access during those, particularly the drought years, and are able to bring more birds into the population. But this really caught our attention and got us thinking about how, in addition to known factors like sagebrush cover and the lack of unfragmented sagebrush rangelands, these birds may be selecting landscapes for breeding and rearing that also relate to mesic resources. Another important finding, the study found that while most of the landscape is publicly owned, 75% of the scarce mesic areas are located on private lands, placing landowners and NRCS in a unique position to help conserve them. So as you see in this figure, the pattern is illustrated really well. The gray areas are public lands, the white private. The green mapped areas are those mesic resources in the summer. And again, the dots represent sage-grouse leks. Notice how the red dots are located somewhat closer to these mesic resources than the blue dots that are out in drier sagebrush uplands. Another key piece of information that really got us excited about the opportunity to work with private landowners to make a difference on this issue. And of course, on the range, water is life. It's a precious resource, and the resilience of these wet areas is equally vital to livestock production and a whole host of other wildlife species, which makes mesic conservation highly compatible with SGI's shared vision of achieving wildlife conservation through sustainable ranching. Yet these mesic areas can be vulnerable to degradation, and we see the signs all across the landscape, whether it's a highly incised stream channel that's abandoned its floodplain, a head cut in a meadow that's just starting to degrade conditions, or maybe even a gully in an upland situation that's just kind of draining the land of that water resource and drying it out. there are a lot of challenges undermining the ability to sustain these mesic habitats, but one widespread problem in meadows and other riparian areas is this issue of channel incision. And so if you look here, in functioning systems with robust vegetation and hydrology, water tables stay near the soil surface, which really affects the surface plant composition and growth. So in the top part of this figure, you notice how a high water table results in a pretty wide valley bottom dominated by wet meadow and mesic vegetation. But when you start to get degradation and channel incision, the water table actually drops. And so you'll see a shift in the vegetation, converting wet mesic vegetation to drier upland species like sagebrush that they don't like to have their feet wet. So that's a good indicator that you have a hydrology problem in your riparian area or meadow. And again, we like to think a lot about surface water, but it's really important to think about what's happening below the ground. And as that water table drops, those green groceries and meadows can dry up. And water table is a key driver of those resources in the late summer. Sometimes local mesic resource issues are only a symptom of broader challenges in the watershed. Here's an example, on the left of a juniper-dominated landscape versus a sagebrush-dominated landscape, and some great research by ARS on this recently published, talking about essentially those juniper-dominated landscapes have earlier snowmelt, less stream flow than compared to your sagebrush steppe landscapes, where snow drifting is really the driving factor that keeps water up in the watershed longer, trickles out over a longer period of time. In fact, it can be delayed in delivery down through your riparian areas by up to 9 days because of that. And so that obviously affects the ability to support riparian and mesic species in your vegetation. On your right, again, looking at herbaceous vegetation matters as well, because poor plant health exposes more bare ground on uplands, which can increase that surface runoff and erosion. Compared to these healthy herbaceous plant communities that you got deep roots, they are doing their biology in the soil that's aggregating and allowing water infiltration to happen, essentially results in a better capacity to capture, store, and safely release water over the course of the summer. So as we started to jump into mesic conservation, we knew it was important. We knew we wanted to do something about it, but immediately our team realized that what exactly are we going to do? How are we going to tackle this issue? And so we sat down as a group across the West, put our heads together, and sketched out a planning guide, so to speak, that we are making available to our staff and to partners. It really just gives a strategic thought process to help others at the state and local level think about how they might want to tackle this issue. Of course, we can do mesic conservation everywhere, and it's quite beneficial, but we have really thought hard about a subset of practices that we think would be beneficial in the realm of the sagebrush ecosystem and sage-grouse conservation. This isn't intended to be a prescriptive cookbook, but it does give our folks and partners some ideas on where to start. So through the lens of grouse, in this guide we've said we're strategically trying to protect, restore, or enhance mesic areas so that sage-grouse hens and chicks can more readily and reliably access forb and insect-rich summer habitats. So that's kind of looking through the lens of a bird. But similar to other threats being addressed through SGI, we're really using sage-grouse as a focal species for targeting ecosystem conservation. And of course, the desired outcomes are much bigger than a single species. Right? So we're using grouse to help us narrow down our realm of focus and work in places where we can make a measurable difference. and the outcomes are much bigger than just grouse. Ultimately, we think it comes down to really promoting the resilience of these systems to support many different ecosystem services in the face of drought and other stressors that come our way. And here's a great example. I was out on a ranch in Wyoming last summer. The photo on your left is an example of a basin that we were standing in where the irrigator that was leasing the land decided they were tired of beaver, trapped them out, removed the beaver dam. Well, that spring we had a flood which resulted in a pretty deep channel incision, and ironically left the irrigation structure here stranded about 2 or 3 feet above the base flows, so they're no longer able to irrigate the field. But just over the hill on the other side of the ridge, in a similar drainage, active beaver colonies left alone, same type of spring flood event, and those beaver dams actually acted, you know, just how they should. Dissipated energy across the floodplain, dropped out sediment. You didn't see the deep channel incision, and that irrigation capacity has been maintained even through a big spring runoff event. And so to me, this is a really great example of the type of function that supports not only healthy ecosystems, but some of the things people want to do as well. All right, so just talking about the conservation actions, and we'll walk through each one of these with some detailed examples and photos for you. But we've identified a subset of practices NRCS and partners can help implement to protect, restore, or enhance mesic habitats. And broadly speaking, those include easements and mechanical restoration whose scope may be a little more limited just due to the high cost. But we've also got a suite of lower cost options that can be implemented perhaps more broadly, such as grazing management with riparian and meadow objectives, spring protection and enhancement, conifer removal, and then some lower cost, low-tech restoration options. Noticeably absent from our strategy are things that are designed simply to protect stream banks, halt erosion, or maybe just reestablish vegetation without actually addressing the hydrology. And we felt that those practices, although they have a place and are beneficial for other things, wouldn't yield the benefits we were looking for with our strategy. Conservation easements are one of the traditional tools in the SGI toolbox. In fact, it's about half of all of our investment so far financially. But they're one of those things that you're going to want to be very selective about. These are a great tool to conserve mesic habitats while helping ranch families pass the land down to future generations intact and healthy. We'll probably want to prioritize these in meadows that, you know, everybody knows birds use a lot in the summer. We have some pretty good evidence, either local knowledge or telemetry data. If you're looking at the graph here on the top right, you know, maybe within your packs, these are your high abundance centers where you have lots and lots of birds. Those are your areas where you're going to want to protect the capacity of the land to just keep doing what it's doing, because the birds are telling you it's pretty good. Mechanical restoration, you know, this is something in cases where degradation is really severe, but potential resource values are high. We may want to do some selective restoration, and you know, this example here is out of Northwest Nevada, involves implementing something like vinyl sheet pilings as a grade stabilization structure to induce sediment deposition and get that water back up to the historic floodplain elevation, resulting in, you know, not only improved mesic vegetation conditions, but forage production for livestock that rely on these meadows. Here's another great example of mechanical restoration. We call this pond and plug. NRCS in Utah helped the landowner restore this incised meadow on the left by excavating a series of sediment detention basins right in the incised channel, plugging them with a low earthen dam, and then recreating a new channel on top of that historic floodplain. So as you can see on the right, from Google Earth and some up-close photos, in just a few years, the ponds had captured over 5 feet of sediment, raised that water table elevation, and rehydrated the entire valley bottom, resulting in a tremendous turnaround in the forage productivity and just year-to-year resilience of that stream and meadow complex. But mechanical restoration is expensive and won't be appropriate everywhere, so other lower cost options may be more widely applicable and accessible to landowners. There's a whole bunch of different simple and cost-effective restoration structures that can be installed by hand, mostly using native materials to restore and enhance these mesic areas. The Z-dike structures are one example. Bill Z-dike wrote a book called Let the Water Do the Work, and these techniques really rely on the power of natural processes to heal degraded systems. Here, they're using sticks and stones to try to put some of these processes back in place and slowly heal the system. In this example, low-profile rock structures are carefully hand-placed to curb head cutting, but encourage vegetation to take root and stabilize soils. In a case study out of Gunnison, Colorado, I want to tell you about, these techniques are becoming increasingly popular because of their low cost and accessibility. A group of partners came together in this part of the world to address these mesic resource concerns, not only from a climate concern standpoint, but also this area supports Gunnison sage grouse. So these are important late brood rearing habitats for that endangered species. And in just 3 years, this working group enlisted the help of over 150 volunteers, crews, students, built 750 of these hand-placed structures, which they estimate affected 23 stream miles. And so we're starting to get to the scale where you may actually see some, reach scale benefits. And importantly, the community is engaged. This is something anybody can do. It does take some training and planning, but really low tech and something that folks can engage in. Just some of the outcomes of that work. Here's an example after a spring runoff event. You see a lot of sediment capture, and again, subtle changes in the vegetation. You get species to take root, growing some of these green groceries to stabilize that channel, and then maybe even some use by your sage grouse populations who are coming into these areas as things get drier in the uplands. And while the changes may be visually subtle, detailed monitoring by local partners in this area is revealing dramatic shifts in plant community composition as degraded sites shift from mostly Kentucky bluegrass here, like in the upper left in 2012, to dominance over time by wetland species and mesic plants, which is a clear signal that you're seeing some hydrologic improvement and change. Another example of low-tech restoration includes beaver dam analogs, or BDAs. And this is something where folks are taking tips from Mother Nature, and BDAs are designed to mimic natural beaver dam activity and really kickstart recovery of hydrologic function, process, and re-establish connection to floodplains in these incised channels. They're becoming increasingly popular, employed by partners all across the West, and early signs show some promising results of being able to achieve a variety of riparian goals. BDAs essentially involve pounding untreated wooden posts across the channel, weaving on-site native materials like willows in between the posts, and you're essentially trying to get that flow to come up onto the inset floodplain and create more complexity, a grade through sediment deposition, encourage more frequent flooding of those adjacent floodplain areas. The structures themselves are low profile, somewhat permeable, and really designed with a short lifespan in mind. They may only last a year, but typically they can last up to 10 years and function quite well. They're not really designed to function in isolation, and usually you're putting in multiple structures for a complex across the reach. Here's the premise behind BDAs and beaver-assisted restoration using a simplified channel evolution model. So if we look here at a degraded system, as it in sizes usually happens very quickly, on the order of 1 to a few years. But as that channel it hits bedrock and widens and takes out some of the banks, it creates its own inset floodplain. That can take a decade or more. And then as it goes through this aggradation process, we're starting to talk about hundreds of years. And then to reach some dynamic equilibrium again could be hundreds of thousands of years, depending upon the system you're in. And so part of what we're trying to do with BDAs is accelerate this recovery process by installing and helping beaver out where they occur to encourage more rapid aggradation and process to short circuit this system so we can see recovery happen in our lifetime. Now here's a case study out of Bridge Creek, Oregon, and this is a intensively monitored watershed through NOAA's program. Conservation partners and scientists in the Pacific Northwest were interested in alternatives to high-cost mechanical restoration for salmonid recovery. So they tested the application of BDAs in terms of stream benefits and also fish population benefits for an endangered steelhead run. Using a really rigorous design, they installed over 114 BDAs covering 4 different treatment reaches, and they had some controlled reaches and paired watersheds as they evaluated the response. And again, note that BDAs are built as part of a complex and not typically as one structure by themselves, which really greatly reduces the importance of any one structure and makes them work in tandem. Following installation of the BDAs, they observed floodplains being inundated much more frequently, water tables rising 1 to 3 feet in places, dramatic expansions in riparian vegetation, and a tremendous increase in habitat complexity, which was important for juvenile steelhead, which they documented a population level response after restoration practices were implemented. All this happened without impacting upstream and downstream migrations of the fish that they had marked. So really encouraging signs as we explore some new innovative lower cost options for Mesic vegetation and stream recovery. Beyond active restoration, some dramatic benefits can be achieved through improved grazing management. In fact, this often goes hand in hand with other restoration techniques. Because riparian and wet meadow areas stay greener longer into the summer than surrounding uplands, they often require some different grazing management strategies. Implementing grazing plans with specific riparian and meadow goals can boost the health and productivity of these vital resources. And here's an amazing example out of Susie Creek, Nevada. In this watershed, BLM staff in the Elko district worked for decades with permittees to promote riparian recovery with livestock grazing, and mostly through adjusting that season of use and providing some off-site water. And so as you can see in 1991, pretty poor shape riparian area. They had been grazing with annual hot season use. By 1999, they had shifted over to some cool season grazing and started to see dramatic changes in the vegetation. By 2007, the beaver showed up and decided it was now a good place to make a living. And by 2014, a gigantic valley bottom there had started to turn into a wet meadow complex. And so, the real take-home, from a ranch perspective, I think is summarized really well by John Griggs, who's the Maggie Creek Ranch manager here and has been part of this project. He said by 2014, even in the midst of severe drought, Susie Creek had water all summer. A lot of my peers were having to haul water to stock. And so that's really the key sales pitch, I guess, from a ranching standpoint, is that even through drought, these areas, when they're resilient, provide important water and forage resources that are pretty hard to find in the sagebrush country. Springs and seeps are also rare resources in Sagebrush Sea, which can make them prone to degradation and often in need of special management. There are a variety of things people can do to protect and enhance springs, but it starts with considering them first in your grazing management strategies, minimizing impacts when we're developing new livestock water, trying to make sure that we have some of that mesic vegetation not lost but maintained on the landscape. And then lots of opportunities exist to retrofit or redevelop existing spring developments that are perhaps not as functional as they once were, and maybe we can redevelop those and encourage vegetation to come back that would support that forb and insect resource base. Finally, targeted conifer removal is another practice that we can put to work in a new light. There's some great new research out by USGS that shows that sage grouse really seek out these higher elevation productive areas, meadows, and productive uplands. But in a lot of the Great Basin especially, they're having to navigate pretty treacherous conifer invaded landscapes to get there. And when they go into those invaded sites, they move faster and therefore are more susceptible to predation. So they've documented reduced survival and even suggested that areas that have kind of the early phase conifer invasion around these meadows and productive uplands may serve as an ecological trap. In other words, the birds go there because they want the food resources, but they may suffer mortality because of it. And so removing those early phase conifer expansion areas adjacent to our mountain big sagebrush communities and mesic meadows can provide tree-free movement corridors for sage grouse to have better access to these green groceries, while also providing that late season water availability and forage production for ranchers.
Now, to help SGI partners scale up mesic conservation, we've developed a whole toolbox of materials to help with planning and outreach. We've got a brief conservation flyer that describes some of the practices that I highlighted in this video. A more detailed planning guide that was developed by NRCS staff to help guide our conservation efforts, but may be of use to other partner agencies as well. An online storyboard that tells the story of mesic conservation and is a useful outreach tool. Also on our SGI website, you'll find an events and webinars page for mesic habitats, where we've got a whole series of videos, past recorded webinars, more in-depth explanation of some of the conservation practices, as well as future events that you may be interested in attending. And then finally, our brand new Mesic resources layer and interactive web app that will be described in other segments of this video. Finally, I just want to close by acknowledging our team effort that it's taken to pull together the science, the communications tools, all of the planning information to help accelerate awareness and implementation of conservation of these really important resources in the West. Thank you.